Today's lesson is about simplifying radical expressions. It's Common Core 9-12 Standard N.R.N.1. A radical expression is an expression containing a radical. Now, radicals include things like square roots, cubed roots, fourth roots, and so on and so forth. But for this lesson, we're only going to be talking about square roots, so every problem will only have square roots. So examples of some radical expressions we may use would be things like 4 square roots of 3 or square root of s minus 7. Both of them contain square roots, and that's what we're going to try to simplify in this lesson. So if you take a square root of a perfect square, the result is an integer, which is rational. So an example of this would be like square root of 49. 7 times 7 gives you 49, so the square root of 49 is 7. Now, unfortunately, some numbers just do not come out evenly. In other words, they are not perfect squares. So if that happens, you might want to use your calculator to get an approximation, a decimal for that, because it's going to be irrational, which means it's going to have a decimal that never goes in any sort of pattern and it never terminates. So an example of this would be square root of 73. There's just not two numbers just alike that you can multiply together and get 73. So if we used our calculator to approximate it, you should get something like 8.54. So let's use prime factorization now so that we can use it in solving some problems, such as square root of 126. We want to reduce this, to simplify this. Well, how do we do that? Well, what we do is we take the 126 and we say, what is the smallest number besides 1 that goes into 126? Well, it's going to be 2, and 2 goes into it 63 times. Now, what is the smallest number besides 1 that goes into 63? Well, it's 3, and it goes into it 21 times. And we keep doing this until we get nothing but prime numbers. You'll notice 2, 3, 3, and 7 are all prime numbers. Now, how does that mean we can reduce the square root of 126? How can we simplify it? Well, in order to pull something out of a square root, you need a group that's just alike. And in this case, we have two 3's that are just alike. Now, what that means is we can pull a 3 outside of the square root. Unfortunately, 2 and 7, they don't have a partner, so they have to stay inside the square root, and we just multiply those terms back together. So the answer on this one, square root of 126, will simplify to 3 square roots of 14. Let's try one more example using prime factorization. So square roots of 72, we want to simplify this example again. So what we do is say, what is the smallest number besides 1 that will go into 72? Well, it's 2, and it goes into it 36 times. Now we do the same thing to 36, and 2 will go into it 8 times. Now what goes into 18? Well, 2 does again because it's an even number, and it goes into it 9 times. What will go into 9? Well, 3 will twice. So now we start going, okay, well, this is a square root, which means we need two things just alike to pull something out of the square root. So we need groups of 2. And you'll notice we have a group of 2's and a group of 3's, which means we can pull a 2 out, we can pull a 3 out, but there's 1 2 left over that must stay underneath the radical. Now, since this time the numbers we were able to pull out, there were more than one number outside the radical, we multiply those, and our answer is 6 square roots of 2. Now we're going to up the ante a little bit. We've talked about how to use prime factorization for numbers. Now let's do that with variables as well. So now we have an x to the 5th, a y squared. That's not something we've seen before in another example. Well, let's treat it just the same. Let's look at the square root of 50 first. So we've got to do prime factorization for it. If we do that, we're going to notice that 5 goes into it twice and 2 does once. Now we do the same thing with the variables. X to the 5th just simply means you have 5 x's underneath that square root. Y squared means you have 2 y's. Now this is still a square root, so even with the variables, we're looking for groups of 2. So you'll notice I've highlighted all the groups of 2, and we got quite a few things that we can pull out of this radical. Now the 8 is already on the outside, so we simply bring it down, and then we start writing each and every one of our groups from our constants to our variables. Now the things that are left inside the square root, well, we had a 2 that did not have a partner, and we had an extra x that we had to leave inside. Now we simplify all the things outside. So we multiply constants together, and then we multiply like variables together. So that's going to give us a total of 40x squared y square root of 2x. This is the final answer, the simplified version of 8 square roots of 50 x to the 5th y squared. Another important skill to have whenever you're talking about radicals is rationalizing the denominator. In other words, we cannot leave a term that has a radical in the denominator. So how do we fix it? Well, with square roots, what we're going to do with square root of 2 is you just simply multiply numerator and denominator by another square root of 2, because a square root times a square root that has the same number inside, well, it cancels each other out. The square root will be gone. So in order to simplify this, we'll do 6 times square roots of 2, which is just 6 square roots of 2. We can't multiply the numbers because 6 is outside the radical while 2 is inside. Now, in the denominator, though, square root of 2 times square root of 2, well, that's 2, because think about it. Really what you're doing is you're multiplying the numbers inside the radical together, which 2 times 2 is 4, and square root of 4, well, we know that's 2. Now, this simplifies a little bit more because the 6 and the 2 in the denominator, well, they're both outside the radical, and 2 will go into 6 3 times. So our final answer is 3 square roots of 2. Now let's look at one of these radicals that is a fraction. So we have the square root of 24z squared divided by 27. Now I've got to simplify this any way I can, and the first thing I notice is 24 and 27, they're both divisible by 3. So I'm going to do that and simplify it. So 24 divided by 3, well, that's 8z squared, and 27 divided by 3, well, that's 9. Now, anytime you have a radical of a fraction, really what you want to do is break it up into two problems. And what I mean by that is this. You do the square root of the numerator divided by the square root of the denominator. It's more or less two problems in one. So let's just look at the square root of 8z squared first. So the 8, let's do prime factorization for it, and then the z squared breaks up into z times z. So now I start looking for groups of 2 because these are square roots, and I notice I can pull a 2 out and I can pull a z out. Well, that's going to mean I have a 2 still left in the radicals, so the numerator answer is 2z square roots of 2. Now for the denominator, the square root of 9, well, we know that one. That's 3. So our final answer for this one is 2z square roots of 2 all divided by 3.